Hi, everybody. Welcome to our first lesson of the year. We're going to be talking about basic probability concepts in this lesson. So let's first actually chat about what is probability. So probability is the likelihood of something occurring. You've probably been using probability for much of your life. Just maybe haven't exactly called it probability, but we all talk about the chances of something happening, the likelihood of something happening. Um, you can express probabilities in several different ways: as a fraction, a decimal, percentage, or in terms of odds. So let's say that Mitch Marner of the Leafs, let's say in 5 shootouts this year, he scored in two of them. We'd like to express that as a probability. Maybe we're watching the next game, goes to a shootout. Mitch Marner has the final shot, and we'd like to say, "Oh man, what chance does he have of scoring here?" Well, as a fraction, we would say, "Well, he has a 2 out of 5 chance of scoring." That's one way to express that probability. Another way would be to divide that and write it as a decimal. So 2 divided by 5, that is 0.4. You could say he has a 0.4 chance of scoring. By multiplying that by 100, you can get the percentage. 0.4 is equivalent to 40%. We can also express probabilities in terms of odds. We'll explore odds a bit later on. We would say the odds of Mitch Marner scoring would be 2 to 3. For every 2 times he scores, there would be 3 times where he misses out of 5. We'll explore odds more later on, primarily in our first few days. And most of our work, actually, we'll be expressing probabilities as either a fraction, a decimal, or a percentage. Let's move on. We're going to talk about some types of probabilities. There are 3 main types of probabilities. The first is subjective probability. This is kind of the probability we use in our everyday life, just chatting with our friends. That's probability based on intuition, kind of like an educated guess based on your experiences and your knowledge. It's always an estimate, though. For example, if I asked you, what do you think the probability of having a snow day is on February 15th? Well, I mean, that's 2 weeks away as I shoot this video. I haven't looked at the forecast, not quite sure what the weather would be. But, like during the wintertime, you might have, I don't know, 1 out of every 20 school days be a snow day. So, I mean, again, this is just educated guess. There's really no perfect right answer. So, 1 out of every 20 winter days are a snow day. Again, you could write that as a decimal or a percent, 0.05 or 5%. I'll add like a little question mark because, who really knows? But roughly 5%. If I ask the same question, what's the probability of having a snow day on April 1st? Based on experiences, it is possible that it could snow on April 1st. So it's definitely not like a 0% chance, but it's probably not as high as, it being a snow day on February 15th. So maybe 1 in 100, like who can say really? But this is just an estimate, or 1%. But again, it's just an estimate. So this is kind of like the casual probability that we might just throw around in our daily conversation. So it's based on intuition, based on experiences. It's an educated guess. The second type of probability we'll be discussing is experimental probability. Now, experimental probability is probability based on experimental trials. Sometimes it's called empirical probability. I sometimes say it's just like the probability based on actually doing an experiment and seeing how often something occurs. So the notation that we'll be using when expressing probability kind of looks like that. So let's just have a quick talk about what some of these things mean. this capital P with the capital A in brackets is just a nice short way of saying the probability of event A. So if we wanted to say, hey, what's let's say something we didn't know, well, I know, let's use rolling some dice, for example. Like you're playing Monopoly, you haven't taken data management before, you're not quite sure what the probability of, rolling, let's say doubles on a pair of dice. Do a little fancy drawing here of a pair of dice. Draw some pips here. A little improvisation. But let's say you weren't sure what the probability was. Well, you could actually just take a pair of dice and roll them over and over and over and over and do lots and lots of trials and hundreds of thousands, however many you want. And you could actually just kind of experiment and see what the probability of getting doubles would be by just doing it lots of times. So on the right side of this here, to find experimental probability of event A happening, well, you just do a bunch of trials and you just count how many times, or the number of times, event A occurs out of the total number of trials. So you can always find the experimental probability of something you're not sure of by actually just performing an experiment. So let's look at an example of that. So as of a couple of days ago, Kyle Lowry had taken, and that's NBA champion Kyle Lowry, had taken 537 shots on the season. So that's from 3-point land to layups. Is just this total amount of shots, and he has made 222 of them. So just roughly speaking, if Kyle's just next shot from anywhere on the floor, what if we want to know his likelihood of making that shot? Well, we kind of have all the tools we need to find an experimental probability here. So we could say the probability of, let's just say, instead of A, we can say probability of him scoring, let's say, would be the number of times, so little n, number of times that he's scored over n of the capital T there. And then just put in what we know. So he has scored 222 times out of 537 times. So that's totally fine as an answer. Like it's a fraction, it's exact, but it might make a little bit, it might be easier to understand if we actually make that into a percentage. So if you divide and multiply that by 100%, I got about a 41.3% chance of making any given shot based on all the data we have. So that's an example of experimental probability. The final type of probability we'll talk about is theoretical probability. So if experimental probability is kind of based on what does happen when you perform an experiment, theoretical probability is kind of based on what should happen. It's based on math. It's based on like analyzing all the possible outcomes in an experiment. So we're going to call the collection of all possible outcomes the sample space. And much like experimental probability, the notation we're going to use is fairly similar. This is just the probability of event A. So that hasn't changed. But on the right-hand side, N of A, this is the number of ways event A, I'll use capitals for that, can occur. The number of different ways that event A can occur. And n of s, this is the number of outcomes in the sample space. So we'll do an example in a second, but maybe just really quickly, most of us have played games with the dice, drew a dice earlier, just like a single dice. It's pretty easy to analyze. 1, 2, let's make it 4 on top. It's pretty easy to analyze probabilities on a single dice. In a single dice, the number of outcomes in the sample space. When you roll a dice, there's 6 possible outcomes, right? And we can actually list those outcomes. The sample space is equal to, and when we're listing a sample space, we use this set notation, a little curly Q bracket. When you roll a dice, the set of all the possible outcomes, the sample space, is just the numbers 1 through 6. And so if, say, we wanted to find the probability of getting a 1, well, we would ask, well, how many different ways can we get a 1? And how many elements are in the sample space? Well, there's 1 way to get a 1, and there's 6 outcomes in the sample space. So the probability of rolling a 1 is 1 out of 6. Now I understand you guys could have figured that out before taking this course, but that just gives you an idea of the notation that we're using. Let's do another example. So maybe if you're watching this video, you can, every time we do a question, you can pause it if you'd like, and then start it up again when you're ready to, just kind of take it up. Just back to my nice green pen here. So we did rolling a 6-sided dice. There's actually lots of different dice. A D20 is a dice used people that play Dungeons and Dragons. Some people use these when playing like Magic the Gathering or other games like that kind of keep track of health or score or what have you. But yeah, D20 has 20 sides, numbers 1 through 20, and they're all equally likely to be rolled. So we would say that the sample space for rolling a D20 is it's all the numbers from 1 to 20. So instead of writing out all those numbers, I might just write it in this fashion here. That's the sample space for rolling a D20. So the number of possible outcomes, 20 different outcomes for rolling a D20. Let's do something with that. What's the probability of rolling a multiple of 3? And we'll find this as a fraction. So we think of, what are multiples of 3 that we could roll on a D20? Well, there's 3, 6, 9, 12, 15, 18, and 21. It would be not possible on a D20. So what that tells us is that the number of ways to, I'll say, roll a 3, we just kind of found out it's 6. And from before, the number of possible outcomes on a D20 is 20. And so the probability of rolling a multiple, maybe I should say like multiple of 3, and maybe you can just, maybe if you're writing your notes, you can put that in there too. Probability of rolling a multiple of 3 is 6 out of 20. Generally, if you're going to leave your answer as a fraction, it's best to put it into lowest terms. That'd be 3 out of 10. Or as a decimal, 0.3 or 30%. But yeah, our first example of theoretical probability. Let's try another one. What's the probability of rolling a prime number? And this time we'll get it as a percent. So prime numbers are numbers that are divisible by 1 and themselves. So technically 1 is not a prime number. The prime number starting from the first prime number is 2. It's the only even prime number. 2, 3, 5. We'll just list all the prime numbers up to 20. 7, 9 is not a prime number, but 11 is. So is 13. 15 is not, but 17 is. And so is 19. So the number of, I'll say, the number of prime is equal to, or the number of ways you can roll a prime on a D20 is 8. And again, the number of elements in our sample space is 20. So the probability of rolling a prime number on a d20 is 8 out of 20. As a percentage, you can divide that and multiply it by 100. As a percentage, that is 40%. All right, another example in the books. Let's move on. Finally, let's do one more. What is the probability of rolling an odd number as a decimal? So again, you can pause and try this problem yourself and unpause it when you're ready. But here we go. The number of ways to roll an odd number on a d20. This might be intuitive to you, but it is 10. The set of all the odd numbers is 1, 3, 5, all the way up to 19. There are 10 of them. And because the sample space is 20, the probability of getting rolling an odd number on a d20 is just 10 out of 20. As a decimal divide, that is 0.5. That is another way to express that probability. So there's a little sampling of some basic theoretical probability examples. You'll do more in your practice a bit later on. Just to go over an important note, a couple important notes. Probabilities are always between 0% and 100%. As decimals, that's 0 and 1. You can't be below 0. You can't have negative probability. And you can't have percentages above 100%. So you've heard the saying, give 110%. Well, you can't do that in probability because 0% means literally impossible, cannot happen. And 100% means something is certain to happen. You can't go beyond certain. It's certain. You don't need to go above that. So probabilities will always be between 0% and 100%. And if you're doing a problem and for some reason that comes out as something more than that, you know that something's up and you should go back and check your work. And one more thing too, the probabilities of all the events in the sample space will add to 100%. So what I mean by that, let's say, I'll just write it this way. The probability of, event 1 plus the probability of event 2 happening plus, the probability all the way up to, the final event. So like all the different events. That's a fancy N, by the way. That will add up to 1. If you add up the probabilities of all the events in the sample space, that'll add to 1. That'll be actually useful later on. This property. But those are two important notes just to be careful of as you're doing problems. And the last thing we'll do in this lesson is just review some skills we'll need with fractions. At times, we're going to need to add or subtract fractions or possibly multiply them. Now, most scientific calculators these days, and you should have a scientific calculator if you're working through this course, but most scientific calculators can do just fraction operations. Your button might look like the following. This is what it looks like on the calculator I'm using right now. It has an A with a B over C. So any new scientific calculator fraction can actually handle doing fractions right away. So technically you shouldn't even have to do them by hand, but it is good to have an understanding of what's going on behind the scenes. And we may use some of these properties later on. So let's do a couple. So let's say we're adding 2 sevenths plus 3 sevenths. When adding fractions, they have the same denominator. That's great. You can just add them. You add the numerators, 5. Denominator stays the same, 7, 5 over 7. The same would go with if subtracting. You would just subtract the numerators. If you don't have a common denominator, you need to find one because you can only add or subtract or combine those fractions that have a common denominator. For adding 1/4 and 2/5, the lowest common denominator would be the product, 20. It's not always the product. For example, if you had a third plus a sixth, then the lowest common denominator wouldn't be 18. 6 would be the lowest common denominator because 3 actually goes into 6. But here, the lowest common denominator is 20, 4 times 5. And we can write 1 over 4, an equivalent fraction over 20 would be 5 over 20, just multiplying top and bottom by 5. 2 over 5, multiplying top and bottom by 4, gives us 8 over 20, and that adds to 13 over 20. Now that they have a common denominator, you can add them together. And finally, when multiplying fractions, that's actually a lot easier than adding or subtracting because you just multiply the numerators, multiply the denominators. 1 times 2 is 2. 4 times 5 is 20, and it's 2 over 20, or in lowest terms, 1 over 10. So yeah, when fraction work does come up, we've at least got some examples in the books, but your calculator should be able to handle any of that stuff on its own. So what are your next steps? As I might have mentioned earlier, I suggest maybe you start a notebook. So for these lessons, you can take notes, get key ideas in there, do your examples in there. If you haven't yet, complete the All About Me task and submit it in the Dropbox. That just is allowing me to know a little bit about you guys and also gets you guys used to using the Dropbox where you're going to submit a lot of your work this year. In this module, I've posted a quiz for you guys to try based on this lesson. These quizzes will be formative. They will not affect your mark negatively. If you nail the quiz and you got everything and you get 100%, then I'll have that recorded and can tie that into your overall mark, albeit weighted very, very small, very small. But these quizzes will not, if you don't do well, they will not count and affect your mark. So just try your best, see what you learned. And I have posted in this module a PDF of practice questions for you guys just to get used to some basic probability ideas, nothing too crazy, but you should try those and make sure you check your answers and let me know if you need some help. So that can be via email or via Google Hangouts if you notice me on. All right, guys, thanks for tuning in. Hope you guys have a great day, and we'll see you later.